Hi, I'm Jenn Servis. I work for the U.S. Fish and Wildlife Service in our headquarters office as a biologist, providing science support for Endangered Species Act decisions. In this talk, I'll discuss the Endangered Species Act listing process and the species status assessment. First, I'll touch on the species status assessment framework, which is our analytical framework for assessing species viability that's used to inform Endangered Species Act decisions like listing determinations. Second, I'll highlight types of information and data we incorporate into the analysis. Then I'll touch on our general workflow for gathering and completing the analysis and making listing decisions. And then lastly, I'll share some examples of bee species for which we have completed species status assessments previously or plan to complete one in the future to inform an upcoming listing recommendation. The species status assessment is a science-focused assessment that we use to deliver foundational science for informing Endangered Species Act decisions using a focused, repeatable, and rigorous scientific risk assessment. Examples of Endangered Species Act decisions that a species status assessment could inform include decisions on whether to add, change the status of, or remove a species from the lists of threatened and endangered wildlife and plants. These assessments can also be used to inform decisions regarding what's needed for a species conservation and recovery, what the greatest research needs are, and how public or private actions may affect the species. The species status assessment framework has three phases depicted here on the right. The first is species needs, and species current condition, and species future condition. In the species status assessment, we use the conservation biology principles of resiliency, redundancy, and representation to characterize the viability of the species, which is defined as the ability of the species to sustain populations in the wild over time. Resiliency refers to the ability of the species to withstand environmental and demographic stochasticity. Redundancy is the ability of the species to withstand catastrophes. And representation is the ability of the species to adapt to novel changes in their physical and biological environment. So now let's walk through some of the common types of information and data used to complete the assessment. First, we gather information on the historical and current range and distribution of the species. The map below is from a species status assessment of the yellow-banded bumblebee that depicts the species' historical range in red, with yellow and black dots representing positive and negative occurrences, respectively. We also collect information on what individuals of the species need to carry out their life cycle. Relevant information here includes species life stages and the resources and circumstances needed to complete each life stage, how flexible the needs are, as well as any key vulnerabilities or pinch points at certain life stages. For animals, we focus on the needs of individuals to carry out breeding, feeding, and sheltering life functions. Shown below is a life history diagram developed for the yellow-banded bumblebee species status assessment, which includes processes, resources, and circumstances individuals go through or require throughout the winter, spring, summer, and fall seasons. We also collect information on what populations need, starting with population structure, which could, for example, be a single population or multiple populations or a meta-population structure. We also look at information on the number, distribution, and boundaries of populations, demographic characteristics such as growth, mortality, and reproductive rates, and also the habitat needs of populations, such as patch size and connectivity requirements. At the species level, we gather information on what the species needs in order to be able to withstand potential catastrophic events, and the frequency, severity, and geographic or temporal patterns of these events. Here is a graphic depicting extremes in drought for the Western US. Severe droughts are a common type of catastrophic event that we consider in our species status assessments. We also collect information on what adaptive capacity the species may need in order to adjust to novel changes in their environment, such as disease, climate change, or invasive species. Here, we often look for information on ecological, genetic, behavioral diversity across the species range, and the species' ability to disperse to suitable habitat. Demographic data from survey and monitoring efforts is key information we use to assess the condition of populations. For populations, we gather abundance, presence-absence data, as well as information on sex ratios, fecundity, survival rates, recruitment, among other kinds of metrics. For example, the map here depicts information we have on zones where the rusty patch bumblebee may occur. For habitat condition, we look for information such as habitat quality, quantity, patch size, and connectivity. It's also helpful to know if the populations have been well surveyed, whether standard protocols were used and can be compared among populations, what percentage of populations have been surveyed, and if the survey information is based on targeted surveys for the species or incidental observations. We also look at how old and generally how reliable the information is. Data collected recently using robust, consistent survey methodology across the range of the species and over time is ideal. However, we use whatever information is considered best available, regardless of when and how it was collected. Also, information on healthy populations and what they need can be useful as well for understanding what recovery of the species could look like. We also gather information on threats and risks to the species, including past, ongoing, and emerging future threats. It's valuable to know about the extent, magnitude, and exposure of these threats, as well as the causal relationships and potential species responses to those threats. In the yellow-banded bumblebee species status assessment, for example, we explored the potential impact of neonicotinoids on individuals and populations, and included information indicating some correlation between neonicotinoid use and the species' relative abundance shown in the graph below. Lastly, we also gather information on conservation actions that may be benefiting the species or mitigating or ameliorating the identified threats to the species. Such conservation plans and efforts may be regulatory or voluntary in nature. We consider both past and ongoing conservation efforts and how they're addressing risks to the species. So we may also identify conservation efforts that are in the planning or pre-implementation stages and how those may benefit the species or its habitat. Also, conservation efforts may not be targeted specifically to the species under review, but may be addressing one of the identified threats to the species. For example, we would consider the implementation of conservation practices that benefit all native pollinators by limiting habitat loss or implementing integrated pest and pollinator management plans. So to summarize, the following are common types of information and data we use to complete species status assessments: species range and distribution, habitat and resource needs, population demographics, current and future threats and risks, and how the species might respond to those threats, and conservation efforts. When making listing decisions, we use the best scientific and commercial data available. Ideally, we begin to gather all of this relevant data and information for the species status assessment at least 2 years ahead of a listing decision during this project planning phase shown here in blue on the left of this workflow diagram below. So let's take a little bit of a closer look at this workflow and discuss the species status assessment and listing process in some more detail. So following that project planning phase that I mentioned, which includes that data and information gathering, we move into the species status assessment phase shown here in green, which includes completing the analysis, writing a report, then having peer and partner review of that report. And we also get input and information from states and other experts throughout that species status assessment phase. And then following that assessment, we move into a discrete decision analysis phase shown here in orange, where we use the species status assessment to inform our decision on whether the species is endangered, threatened, or not warranted for listing. The species status assessment report is intended to provide the biological support for a decision on whether a species warrants listing. The report itself is not a decisional document, rather provides a review of all the available information and is strictly related to the species' biological status. The separate decision document is then written, reviewed, and surnamed before it's made public. And this diagram depicts the listing process and how the species status assessment workflow we just saw fits into this larger listing process. There are two processes we can follow to list a species: a discretionary status review or receipt of a petition. Most listing decisions are made as a result of receiving a petition to list a species. First, we make an initial finding on whether the petition presents substantial information indicating the species may be warranted for listing. If the petition does provide substantial information and we make a positive initial finding, we then complete a species status assessment as part of a more in-depth evaluation of the species. That species status assessment informs our 12-month finding on the petition, which will result in either a finding that the species is not warranted for listing or that the species is warranted for listing, in which case we most often proceed directly to the rulemaking stage and publish a concurrent warranted 12-month finding on the petition and a proposed listing rule. Our National Listing Work Plan is our long-term schedule for listing actions, including petition findings, listing determinations, and critical habitat designations, and is based in part on a prioritization methodology we have for petition findings. This work plan provides predictability to states and other partners we work with on what actions we're doing and when. It's flexible to address new species whenever needed. It aligns and mobilizes conservation delivery. It reflects biological priorities, distributes workload for us across the country, and creates efficiencies by batching actions when possible and combining warranted 12-month petition findings with proposed listing and critical habitat rules. And this National Listing Work Plan is publicly available online. So we've completed listing decisions for several bee species that were on our work plans and were informed by species status assessments. In 2017, we listed the rusty patch bumblebee as endangered, and we developed a species status assessment to inform that decision. Also in 2019, we completed a species status assessment for the yellow-banded bumblebee, which informed our determination that the species is not warranted for listing. And just this year, the Franklin's bumblebee was listed as an endangered species. Upcoming species status assessments and listing decisions can be found on our publicly available 5-year National Listing Work Plan. We have future listing decisions coming up for the western bumblebee, Mojave poppy bee, and blue calamintha bee. And we also just recently published a substantial 90-day finding on a petition to list the American bumblebee. So upon listing a species, we move into recovery planning, and the species status assessment that we developed for the listing decision can also be used to inform recovery. Additional information and data beyond that which was incorporated into the species status assessment for the listing decision may be analyzed at this stage to help develop recovery vision, actions, and criteria. The species status assessment for the rusty patch bumblebee is a really excellent example of an assessment that informed both the listing decision and recovery planning, for which conservation units mapped here were delineated and used to develop recovery criteria. And even with that assessment, additional data on the composition of healthy populations would have been very informative in developing the recovery plan. For example, baseline genetics data, pathogen loads, and colony sizes would have been really useful information to help inform recovery targets. So thank you so much for your time and your interest in the data we use to develop species status assessments and inform Endangered Species Act listings and recovery planning.